8.8. In this lecture video, I'm going to show you how some application problems using compound interest formula. All right. So the idea of a compound interest formula is basically like a snowball effect, a tiny little snowball on top of the hill. When we roll it down the hill, once it reaches the bottom, it's going to be a big old snowball. Okay. So what that means is as the years goes on, okay, when we calculating a compound interest, okay, what you the amount of money is actually accumulated, okay, is actually being compounded based on how many times in a year. So by the end of the term, the money will be growing bigger and bigger and bigger. So basically, we use compound interest formula for more like investment type of problem. So real quick explanation. Let's say we put $1,000. Okay, put $1,000 into some sort of mutual fund account or something like that, and invest it at 10% a year. Okay, for 5 years, for example. So if I'm using the simple interest formula that I introduced in the previous video, that will be principal times rate times time. So let's do this 1 year at a time, okay? So real quick, $1,000 times 0.1 times 1 year at a time. So because I want to compound annually, my account rolls over, okay, accumulating more interest year by year. Okay, it's called compound annually. So this is the interest that I earned. Okay, since I'm investing money, this $100 is what I earned by putting my $1,000 in this account. So that's the first year. So second year, okay, I don't take my interest out. So if the interest stays in this account on top of my $1,000, the second year I should have $1,100. So take my $1,100, invest at 10% for another year. So my next year times 0.1 times 1. At the end of the second year, that same account will actually earn me the interest of $110. So why it is not $100? Because my second year, the principal is no longer 1,000. It's actually the 1,000 plus 100, okay, that I earned from the year number one. So that means at the end of the second year, I should have $1,100 plus the 110 interest I earned from the second year. So now going to the third year, my principal now is 1210. Okay, this is how much money in my account. So I'm going to do this one more time, times by 10% times doing this one more year, compounding annually. So as you can see, 1210 times 0.1 times one more year. Now, the third year actually earned me even more interest compared to the previous 2 years alone, $121. So this is the compounding effect because I keep on using the previous year's interest add on to the principal as my next year's principal and keep on accumulating my interest. So the amount of money in my bank account is getting fatter and fatter, which is what we want. All right, that's the idea of a compound interest. So we can formulate them into this formula called A equal to principal times parenthesis 1 plus R over N and whole thing to the N times T power. So P stand for the principal, the amount invested, or it can be as a borrowed. But most of the time, borrowing money is not really using compound interest. It's using a different type of interest. Okay, there's many different types. Okay, out there as far as borrow money wise. The simple interest formula is just the most fundamental type. All right, R is my annual interest rate. Okay, so I'm taking my principal down to a bank or put it into a mutual fund, earning at so many percent. T stand for year, N stand for the number of compounding period in a year. So in other words, basically is talking about what N stand for is how many times does my snowball is gonna roll over, make a one complete cycle. Okay, before before I can take the interest and add on to the principal and then do it and then using the formula and earn me more interest. How many times am I doing that in a year? So the example I give you was compounding once a year. There are different ways we can do compounding. All right, annually. If it's compounding annually, that means my n is equal to 1. So that's why I will put 1 in the formula. If I'm compounding semi-annually, that means my account will roll over, okay, twice in a year. So it will do the computation I just showed you 2 times in 1 year. All right, quarterly means it will roll over 4 times in a year. Monthly is 12, and daily will be 365. Okay, so once I can figure out the total amount that's in my account, then to figure out how much interest is earned, I can just take the total amount minus the money I put in, which is the principal. All right, so let's try it. Okay, I'm going to write down the formula a couple times. If an account is compounded monthly, so right there, when they say compounded monthly, say the word compound tell you to use the compound interest formula. Whole thing to the n times t power. Monthly means my n is going to equal to 1. 18% is my R. How much interest will a principal of $10,000, that's where the P going to be, earn in 59 months? Okay, so let's put the P here. $10,000 times 1 plus my interest rate, 18%, which is 0.18, divided by compound. Oh, sorry. I did not mean to say n is 1. Compound monthly n is 12. Sorry about that. All right, whole thing raised into n is 12 times time. Time is always going to be in term of years. So 59 months is my time, but that's not in years, it's in months. So we will say that's 59 months out of 12 months in the year. Okay, so that will be my exponent. It's an exponential explosion on the money you invest. It's called the compound interest formula. So I'm gonna just show you how to enter all this in the calculator at one time. Okay, so 10,000 times parenthesis 1 plus 0.18 divided by 12. So the calculator sees this addition sign in the parentheses separate between 2 terms. So it will naturally take the 0.18 divided by 12 first. All right, your exponent notation is this caret key. Some scientific calculator might have something like x to a box, something like that. Okay, that's also an exponent key. So if you cannot find your exponent key on your calculator, please let your instructor know. He or she will gladly to show you where the exponent keys are. So now all these things here up here are exponents. So I'm going to let the calculator do this for me. So I would need to put this operation in another parenthesis and say 12 times 59 over 12. Okay, we'll just type in just like that. And this will be how much money will be in the account. 24071. 24071.13. Okay, always round to the near cent. So this is a total amount, but the question is asking how much interest will be Okay, how much interest will I earn? So we take the total amount at the end of 59 months and minus the money I put in, which is 10 grand. So that will give me this account alone after 59 months will earn me $14,071.13. So that will be my answer. That's how much interest I earned. Okay. All right, let's try several more. So I'm just gonna kind of give you different examples on what the N is, how many times we compound in a year. So invest at $8,700 at 11% to be compounded semi-annually. So when you see the word compound, we're gonna use our compound interest formula. When you see the word semi-annually, that means N is 2. So let me write the formula down. A equal to principal times parenthesis 1 plus R over N to the N times T power. Let's check it out. All right. Invest $8,700 times 1 plus 11% is 0.11 divided by compounded semi-annually. N is 2. Whole thing raised into the 2 is N times the time, which is 2 years. So if you want to, you can say the exponent is basically 4. So what that 4 means is the account will roll over 4 times total, right? Twice a year for 2 years, it roll over 4 times. So this time I'm going to just simply type in a 4 on my exponent. 1 plus 0.11 divided by 2, whole thing raising a caret key to the 4 power. So that will be 100. That'll be 0.11. Yep, that will be 107,000. No, that would be $10,777.77. Okay, what would be the value of Wang's investment in 2 years? So that will be the total amount. Okay, his investment will be worth slightly over $10,000. So this one is not asking for interest. So this is my answer, the total amount. All right, so this one is compounded daily. So watch. Note 365 days in a year now. So daily, this time want me to use 365. So David invested $45,400 at 19% compounded daily. What would be the value of David's investment in 3 years? Okay, so let me just copy and paste this formula real quick. Let me move it down here. So let's take a look. Let's punch in some numbers here. All right, P is $45,400 times 1 plus 0.19 divided by N is 365. Whole thing raising to the 365 times 3 years. So times by 3. So this time I'm going to let the calculator do this for me. So let's say if you have $45,000 on hand, invested at 19% compounded daily for 3 years. Let's see how the money grows on tree right here. 45,400 times 1 plus 0.19 divided by 365, raising to the parenthesis, right? I'm going to let the calculator do this for me. 365 times 3. Now, if you don't put this in the parenthesis, the whole answer will actually be off, because the calculator will end up doing, without parenthesis, the calculator will only raise into the 365 power, okay, and at the very end, okay, times by 3. So that's actually incorrect. So let's see. My money grows on trees become $80,000, 267. And 42 cents. Okay, that's how much this $45,000 will worth. Okay. So some students argue, well, Mr. Chen, who has $45,000 on hand? Okay, well, a lot of people retire, or a lot of people who sold their house, okay, after 30-year mortgage, okay, they decided to move to a different place, okay, or they sold their house where they have extra money, they can actually put them into investment. Okay, it's possible. It's possible. People do this. All right, if an account is compounded annually, so this time it's compounded annually. So n is 1. 6%. How much interest? So this problem asking for interest again. Well, a principal of $25,500. All right, so let's see. Let me just kind of copy my formula over. I'm just plug it in. So $25,500 times 1 plus 0.06 divided by compound annually n is 1, raising to the 1 times t. T is normally got to be in years. This 9 is actually in months. So that will be 9 months out of 12 months in a year. Okay. So let's see. 25,500 times 1 plus 0.06 divided by 1, close parenthesis, raising to parenthesis. I'm going to say 1 times 9 over 12. Okay, I'm going to let the calculator do all that for me on the exponent. Or $26,000. $639. And let's see how many cents. 10 cents. Okay, so check this out. All right, Mr. Chen, nobody got this kind of money to invest. Let me do it this way. Let's say we're going to buy a new car for $25,500. Okay, this is my new car. I'm gonna purchase this rather than pay people 6% interest. I'm gonna invest at the same 6% interest, and I'm gonna do this for 5 years. Okay, do this for 5 years. All right, 5 years, 60 months, right? So let's do 60 months. I'm gonna show you 60 months. So this problem, I'm actually gonna do compound monthly. So same scenario as if somebody will buy a car, because you make payment monthly, right? So I'm just gonna come here and type this in. 25,500 a new car. If I would take that same money and invest it, 0.06 divided by compound monthly, for example, n will be 12, raised into parentheses, n is 12 times. Doing it for 60 months, that will be 60 out of 12 months in a year. That same car that was costing you $25,000 5 years ago, if you take the same money, invest it instead, that same money becomes $34,000. Okay, so as you know, cars depreciate over time. So instead of buying a new car, making monthly payments, if we take the same amount of money and invest it, that money will actually go up rather than depreciate. And that is what we so-called opportunity cost. Money go one place, cannot go the other place, called the opportunity cost. Okay, this is people's choice what they want to do with their money. Alrighty, so this one is an example of compound quarterly. So quarterly is n equal to 4. Alright, so let's use the same formula, compound quarterly. What would be the value of Steve's investment? Well, let's check it out. quarterly means the account will roll over 3 times in a year. Trying to copy this formula. All right, so let's try this one more time. 44,900 times 1 plus 6% again, but this time compound the quarterly. Quarterly means that my account will roll over 4 times in a year. So raising to the 4 times t power, which is another 4. So 4 times 4 is 16, so that means the account will roll over 16 times total in this duration. 0.06 divided by 4. This time I'm gonna just say raising to the 16 power. So easy multiplication. I'm just gonna type it in. Something complicated, I put them in a parenthesis, let the calculator do it for me. So my answer 56,977 and 45 cents. Okay, so right. So compound interest, most of the time we use it as for investment. Okay, so just a quick few example on how we can use compound interest formula. All right, that will conclude this lecture video. Thank you for watching.